Good day everyone, I am Charlotte Baylon, and today I will be discussing mostly on the what to know side about the Young's double slit experiment. So let us start with the definition. Thomas Young, who is the founder and the proponent of the double slit experiment, is famous for demonstrating the principle of interference. So in fact, he had established the principle of interference of light and thus resurrected the century-old wave theory of light. So Thomas Young performed an experiment that strongly interfered the wave-like nature of light. So because he believed that light was composed of waves, Young reasoned and some type of interaction would occur when two light waves meet. So this interactive tutorial explores how coherent light waves interact when passed through two closely spaced slits. So Young's double slit experiment uses two coherent sources of light placed at a small distant apart. So usually a few orders of magnitude greater than the wavelength of light are used. So Young's experiment was based on the hypothesis that if light were wave-like in nature, then it should behave in a manner similar to ripples or waves on a pond of water. And where two opposing water waves meet, they should react in a specific manner to either reinforce or destroy each other. If the two waves are in the step or the crest meet, then they should combine to make a larger wave. So in contrast, when two waves meet and that are out of step, the crest or one meets the trough or of another, the waves should cancel and produce a flat surface in that area. So how did it started? In May of 1801, while pondering some of Newton's experiments, Young came up with a basic idea for the now famous double slit experiment to demonstrate the interference of light waves. So Thomas Young performed his experiment in 1804, long before we knew anything about electrons or the subatomic world. So the original Young's double slit experiment used diffracted light from a single source passed into two more slits to be used as coherent sources. So lasers are commonly used as a coherent source in modern day experiments. In the early 1800s, 1801 to 1805, depending on the source, it is when Thomas Young conducted his experiment. He allowed light to pass through a slit in a barrier, so it expanded out in wave fronts from the slit as light source under Huygens principle. The light in turn passed through the pair of slits in another barrier. And each slit in turn diffracted the light as if they were also individual sources of light. The light impacted on the observation screen. So here is the image. When a single slit was open, it merely impacted the observation screen with greater intensity at the center and then faded as you move away from the center. So there are two possible results of this experiment. We have the particle interpretation. If light exists as particles, the intensity of both slits will be the sum of the intensity from the individual slits. And in wave interpretation, if light exists as waves, the light waves will have interference under the principle of superposition, creating bands of light and dark, which is a destructive interference. When the experiment was conducted, the light waves did indeed show these interference patterns. So here's a short video clip, and it's not a clip, it's actually a moving image on how the Young's double slit experiment works. So Young observed that when slits were large, spaced from apart and close to the screen, then two overlapping patches of light formed on the screen. However, when he reduced the size of the slits and brought them closer together, the light passes through the slits and onto the screen, which produce distant bands of color separated by dark regions in a serial order. Young coined the term interference fringes to describe the bands and realized that these color bands could only be produced if light were acting like a wave. So, over the years, the experiment had been conducted in a number of different ways. Um, Plus, Johnson performed the experiment with electrons, and it conformed with Young's behavior, and it creates an interference pattern on the observation screen. So Johnson's version of the experiment was voted the most beautiful experiment by physics world in the year 2002. So in 1974, technology became able to perform the experiment by releasing a single electron at a time. So again, the interference patterns show up, but when a detector is placed at the slit, the interference once again disappear. So the experiment was again performed in 1989 by a Japanese team that was able to use more refined equipments. So the experiment has been performed with photons, electrons, and atoms, and each time the same result becomes obvious. Something about measuring the position of the particle at the slit removes the wave behavior. So many theories exist to explain why, but so far it is all conjecture, or it is all merely their opinions. Oh, so that's all. That's the end for our Young's double slit experiment. I hope you were able to listen properly and you were able to get informations which are relevant to Young's double slit experiment. And thank you for listening.